Get ready for takeoff. Hydrogen-powered airplanes set to revolutionize aviation by 2028. Get ready for the hydrogen-powered airplanes revolutionizing aviation. In 6 years, the first commercial flight of a passenger plane powered by hydrogen could take place between Rotterdam and London. This is part of a plan to make short-haul flights less harmful to the environment. Picture this: a world where airplanes produce zero emissions, drastically reducing carbon footprints and offer longer flight ranges. Hydrogen-powered airplanes are here to make that vision a reality, thanks to recent advancements. A Dutch consortium has set a big goal for 2028. Airbus said 18 months ago that it wanted to be the first company to offer commercial aircraft models that run on hydrogen and have no emissions by 2035. Hydrogen doesn't give off any carbon or greenhouse gases when it's burned. This makes it a clean fuel option for planes as well as trains and trucks. But the process of making hydrogen is only clean if the energy used is renewable, and the way it's burned can cause air pollution that is bad for your health. So, how does it work? These next-generation aircrafts use hydrogen fuel cells, which convert hydrogen and oxygen into electricity, powering the plane's engines. The only byproduct? Pure water vapor. Hydrogen can be used in a fuel cell as a power source in aircrafts by combustion in a modified jet engine. It can even be used to create synthetic fuels, which are discussed separately in this series. The high energy density of hydrogen, which is roughly 2.5 times higher than that of jet fuel, and potential for zero CO2 emissions make it an attractive alternative to conventional jet fuel. But to make hydrogen a viable fuel to decarbonize aviation, the industry will require radical new aircraft designs and a scaled-up low-carbon hydrogen supply. How does hydrogen propulsion work? In a gas turbine engine, ambient air is drawn into the engine, where a compressor raises the pressure and feeds the air into the combustion chamber. Fuel is later on injected into the combustion chamber, mixed with the high-pressure air and burned. The resulting hot, high-pressure air is what generates thrust. Jet engines pull oxygen from the surrounding air, unlike rocket engines, which carry oxygen. With certain modifications, jet fuel-burning gas turbine engines can combust hydrogen in place of conventional jet fuel. Hydrogen emits no CO2 emissions during combustion, but overall emission will depend on how the hydrogen is produced, and nitrogen oxide emissions are still a concern. With this technology, the aviation industry can finally take a giant leap towards achieving its sustainability goals. Hydrogen fuel cells offer a more environmentally friendly alternative to traditional fossil fuels. Hydrogen can also be used to generate electric power in a fuel cell, a device that converts the chemical energy in hydrogen to electrical energy and heat through a series of reactions involving oxygen, with a byproduct being water. Fuel cells can be used independently for propulsion in propeller aircrafts, but at the same time, given the power density limitations of fuel cells, long-distance flights with heavy payloads are likely to only be powered partially by fuel cells. To increase range and payload size, fuel cells can also be used in a hybrid electric propulsion system with a hydrogen-burning gas turbine engine. In a hybrid system, the fuel cell acts as the main power source during cruise flight, and the gas turbine is designed to deliver the major thrust for takeoff and climb. Environmental benefits of a hybrid system include improved fuel efficiency and reduced nitrogen oxide emissions and contrail formation. You might be wondering why this matters. Well, air travel is responsible for around 2.1% of global emissions, releasing close to 1 billion tons of carbon per year. While flights have decreased since the COVID-19 outbreak, proactive measures to reduce emissions as travel ramps back up again are essential. Hydrogen fuel could help transition the aviation sector toward a more sustainable zero-emissions future. Hydrogen power is crucial for decarbonizing some of the hardest transitioning sectors, such as cement, steel, aluminum, and aviation, because of its unique ability to produce intense heat similar to oil and gas, according to Hydrogen Forward, a coalition of companies working to make hydrogen a key contributor to the clean energy transition. There are many ways to turn hydrogen into energy. Based on climate friendliness and reliance on fossil fuels, these methods are assigned a hue on a color-coded scale known as the hydrogen rainbow. Nearly all hydrogen fuel cell plants in the US rely on the stream methane reforming processes, which uses natural gas to feed circuits. These methods, relying on fossil fuels, produce gray, brown, and black hydrogen. Nuclear is considered pink hydrogen, and electric is turquoise. Though used for decades, these colorful methods are considered too inefficient, small-scale, or dirty to be viable clean energy alternatives in the long term. Hydrogen power has the power to be a force in the clean energy sector. Still, the newest and most exciting color of the hydrogen rainbow is green, which is a cleaner way of producing hydrogen using renewables, cyanobacteria, or algae. According to industry experts, getting to green hydrogen is impossible without mastering the other colors on the spectrum, but green is the goal. But the method used to produce it will define its effectiveness. What are the technical challenges? The global aviation industry will need to overcome significant technical challenges in order to make hydrogen propulsion a viable alternative to traditional jet fuel. One of the greatest hurdles is fuel storage on board aircrafts. A much larger volume of liquid hydrogen is required to give the same amount of energy as traditional jet fuel, and it needs to be contained at very high pressures and low temperatures to maintain a liquid state. Most commercial aircrafts store fuel in the wings. However, the large fuel tank size required to store liquid hydrogen means the fuel tank must be located in the aircraft's main body, or fuselage, instead. This creates a trade-off between fuel storage and passenger capacity. Another major challenge is assessing the non-CO2 related climate impacts of hydrogen combustion. At cruising altitudes, water vapor interacts with soot and particles in the atmosphere to form trails of condensation and contrails. These contrails have a short-lived effect on atmospheric temperatures, with a lifetime ranging from a few days to a year. While hydrogen combustion emits no CO2, it emits nitrogen oxide and nearly 3 times more water vapor than fossil-based jet fuel. Initial simulations suggest that hydrogen combustion reduces contrail formation, but more research, particularly airborne research, is needed to understand the climate impacts of hydrogen combustion fully. Hydrogen-powered airplanes have the potential to revolutionize aviation. They reduce greenhouse gas emissions and mitigate noise pollution, making air travel quieter and more eco-friendly. But that's not all. Hydrogen-powered airplanes also offer significant improvements in flight range. With traditional fuel, planes require frequent refueling stops. But hydrogen fuel cells provide longer endurance, allowing for non-stop, ultra-long-haul flights. Imagine flying from New York to Tokyo without having to stop for refueling. Hydrogen-powered airplanes are making this dream a reality. The aviation industry already embraces this incredible technology, with major manufacturers investing in research and development. We can expect to see hydrogen-powered airplanes taking to the skies in the not-so-distant future. So get ready for a cleaner, greener, and more efficient future of air travel. The era of hydrogen-powered airplanes has arrived, and it's about to take off to new heights. What are your thoughts on this? Tell us in the comment section below. And if you enjoyed this video and found it interesting, then make sure to leave us a thumbs up. And don't forget to subscribe to our channel and click on the bell icon to always be updated with the most exciting content as soon as it's uploaded. Thanks for watching. See you in another video.